Hello everyone, welcome back to some more Tametsi. We're going to find out today whether it's going to be another 6-minute episode or another 50-minute episode. We're going to work on 85, Endless Knot. It does look like a knot, yep. We have a lot of A's and a lot of B's, so we're not going to work on that just yet. We therefore need to look at Minesweeper clues. Also, there's no edge clues. This is just like a Minesweeper game, practically. Only eventually, someday, we'll probably have to look at colors. Mostly, this is just like a pure Minesweeper puzzle. How nice. I don't assume that means it'll be easy, by any means. Where do you even start? This 6 is promising, right? There's 7 neighbors next to it. And, no, it's not. I just want like a Sword of Damocles for this knot, haha. Go look that one up. There aren't any obviously good starting points. There's not much that, I mean, I don't know. This 4 and this 3, I guess, maybe, something? We see that pattern in a few places, so I guess it's worth looking at briefly, although I'm not sure it really helps. We have at most 3 here, which means at least 1 here, which means at most 2 in this area, but that doesn't really help. Yeah. All right. Like, is there a 4 next to a 2 somewhere? There is. Here, right? So we have at most 2 in this area for this 2, which means these 2 must both be mines to satisfy this 4. I almost clicked on them. At least it would be a quick restart, huh? There you go. Now this 2 and this 2 have all their mines here and therefore none over here. And I think we can continue working out from here, right? We have exactly 3 here, which means exactly 2 here, which means exactly 1 here for this 3. So this 2 needs exactly 1 in this area, and that means this 2's second mine must be here. And I think we can take this backwards somewhat, maybe? Maybe not. No. We know the same thing's going in the other direction. Okay. We do know there's 1 here and 1 here. I don't quite see how that's useful, but okay, sure. This 3 is next to a 2, and this is the only space that the 3 could have its third mine in, therefore. Now these 2's are sharing these 3 spaces, so this is all safe. And a 2 by a 1 here puts a mine there. Now this 2 next to this 1 is something. It might have been something already, actually, before. No, because we could have had both of these. But now we can't have both of these, so there's definitely a mine here. And in addition to those zeros, it gives us this square. Wait a minute, is that right? Yes, it is. I thought I clicked it because of this 1, and that didn't look right, because the 1 didn't turn gray. But it is true because of this 2. That one needs to go there. No, it doesn't. That's something I really got to pay more attention to, is if I mark something a mine, because it has only one neighbor and it doesn't turn gray, like, stop, go back, you miscounted mines. We still have this A. Anyway, we have zeros up here, though, to work with. 2 goes there. These are zeros now. 1 there. These ones go here. These ones go here. We have zeros anyway. Got it. This 1 has to go there. The 5 next to the 4 is maybe something now. It wasn't before, but I think it could be now. I mean, I guess we can improve what we know here a bit more. There's 1 here, therefore 1 here. Therefore 4 in this area. Which still only means at least 2 as far as this stuff is concerned, but we've narrowed it down a tiny bit. But what I'm looking at is this 5 right now. It can only have 2 mines down here, which means it has at least 3 in this area. So we have at most one of these 2. Which means at least 2 of these for this 3. And that finishes the 2 here, doesn't it? No, that's a 3. Okay. But it means there's at most one of these 2 then. Which doesn't really help. Okay. But now that this is all closed off, we have this 2 next to the 3 going somewhere. There's 2 of these, and this is the 3rd mine for the 3. This 3 looks important. It's next to this 2, so it has at most 2 mines in this area, which means at least 1 here. That actually sucks. Let's look at it another way. There's at least 1 in any pair of mines that this 3 is adjacent to, because there's only 4 of them, right? And so in particular, at least 1 here. Which means this 2 has at most 1 in this whole space. So to finish this 2, we need a mine here. And now I think we can go the other direction a bit. Let's erase this nonsense. This is still at least 1. But we have exactly 1 here. Therefore, for this 2, exactly 1 here. So this 4 has exactly 3 in this area, which means this 4 has exactly 1 here. So this 5 has 4 of these 5 spaces, I guess. I thought that would be more useful, but I can't seem to do anything with it just yet. Well, okay, maybe we can go down this line a bit. This 3 next to this 3 doesn't say all that much, but the 3 next to the 2, we need at least 1 mine here. No. We need at least 1 mine here to be the 3rd mine for this 3, right? Because it has at most 2 in this area. But also there's at least 1 in this area, because that, like, the 3 can only hide 2 of its mines up here, right? there's at least one here, which means there's at most one of these two for this 2. Which means there's at least 2 in this area to make this 3 finished. And that gives us this 2. It has no mine here. Okay. This 1 and 2 are sharing these spaces, which puts exactly 1 mine here, the second mine for the 2. And then exactly 3 mines here, which gives us the 4th mine for this 4 as here. We can't trace that deduction backwards. We don't get anything new. Oof. So this 3 has at least 1 shared by this 3, right? It can only hide 2 of them down here. There's at least 1 in this area, which I'm not going to draw in at the moment. Oh, but that doesn't help. Does it? No. That's why I won't draw it in, because it doesn't help. What about this stuff up here? Can we do anything here yet? Wait. Isn't this useful? Well, we have exactly 2 of these mines, right? 2. Which means 2 here to satisfy this 4. Which means 2 here to satisfy this 4. Which means 1 of these to satisfy this 3. To satisfy this 3, we need 2 in this area, which finishes this 2. So these are not mines. Well, okay. That didn't... Yes. Now that we've got this 1, we have 1 of these 2, but also for this 1, 1 of this group of 4. So it can't be either of these 2. Well, I mean, we have 1 of these, and therefore 1 of these, which is kind of cool. Yes. Because there are now exactly 2 here to finish this 3. But since we know there are 4 in this group, and only 2 here, the other 2 must be these 2. So let's draw that in. This is the first, well, a lot of the deductions I've been doing for the last while have been pretty local, and I've been willing to, like, okay, I figure out what they do, and I erase them, or I figure out they don't do anything, and I, like, usually erase them sooner or later. But here, there are so many areas that I need to work on going back and forth between them that I'm finding it useful to leave deductions lying around because they just might interact with some others, right? I don't know if I would have remembered this 4 when I deduced the 2 here, and so having it still there was very useful. And so this 2 is good, right? Because for this 1, we have exactly 1 here, which means exactly 1 in this area. And since there have to be 2 mines here, the 1 mine this 2 is seeing must be one of these 2. So it can't be here. And the second mine in this area must be here. And we can now simplify this to exactly 1. Maybe I can even resolve which one it is, but anyway, we can do that much. I mean, okay, let's just draw some more stuff we know. We know there's 1 here. No, we don't. We know there's at least 1 there. If we knew there were 1 there, that would be great. I could then resolve this whole... Well, I could resolve this mine and this mine. That would probably give me the section, but not necessarily. Where have I made progress recently that might want some help? In this area, I guess. I mean, for what it's worth, I do know exactly one of those two. I'm not sure how that'll help, but let's write it down. Well, there's exactly 1 here. It means there's exactly 2 in this whole group. Does that help? Not really. It means this 3 has at least 1 being contributed by this 3, but we already knew that. How about this 2 and this 3? Is that anything? I wrote at least 1 here, but I don't think that's actually necessarily correct, is it? Maybe I derived it from down here and it was okay, but I don't think so. Because really, well, there's at least 1 here in this group of 2. Give me like a grayer black so I can see it crossing this divide. Oh my god. That looks horrible. Right? There's at least 1 there because this 3 can only have 2 mines in this area. I'm not sure how I concluded there was at least 1 here. Doesn't really make any sense, as far as I can tell. I want this 5 to give me something to do with these A's. I don't think it does, though. What about this 3? Did I look at this before? It has at most 1 here, right? Which means at least 2 of these. There you go, my worst notation yet. Which in particular means at least 1 of these 2. So there's at most 2 in this whole area, which doesn't seem to matter very much. Yeah, this is just such a lame deduction. I'd rather leave more space on the board, to be honest. I will erase that one. This 3, I guess, has at least 1 here, because it can't share 3 of them with the 2. And that means there's at most 2 here. Doesn't seem useful. this 4, we need at least one here. And furthermore, there's at least one in this area because the 4 just can't fit all 4 of its mines up here. But that just means there's at most 2 of this one mine, which is a very uninteresting conclusion. Three, 4, 3. We've looked at this before, and I don't think it's that useful, is it? We have at least one here to avoid messing up this 3. And likewise at least one here to avoid messing up this 3, right? So there's at most 2 in this area and this area. But that doesn't seem important. It just affects this 3. This 3 is like, oh, at most 2 of these? Who cares? There are only 2 squares there, right? So I don't think that's helpful. Is there anything else I can do before I like erase this stuff? Maybe I'll just leave it. It's not like it's getting in the way, right? I'm not doing anything else down here as far as I can tell. I have at least one of these. Oops. I have at least one of these 2. Because the 5 just has to put one there, which means I have at most one of these 2. That means there's at least 2. For this 3, right? We have at least 2 in this area, which means at most 1 here to finish off this 3. Is that useful somehow? I don't think so. I mean, it's new information. That's nice. There's at least one mine in these 2 spaces. I mean, pretty much any pair of spaces we could say that about for this 3. Maybe that's why I put at least one here before. It was correct, because the 3, any pair of mines, right? But if there's at least one here, does that mean anything for this 4? There are at most 3 in this whole area. I don't think that helps. We can do something down here. I don't know if it's leading anywhere, but look at these 3 spaces. They have at least 2 in them, right? Because of this 3 can only put 1 up there. And that means that there's at most 1 of these 3. And 2 of those are touching this 4. So it can be at most 1 mine here, which means in the remaining 5 spaces, there are at least 2. One of them could be up here, but then there's at least 1 touching this 3. It doesn't matter, we just get at most 2 of this tile, which we already knew. I think we derived that already before. these two threes next to each other, this 3 has at most 1 in this space, and therefore at least 2 here. So there's at most 1 here. Does that help somehow? It means at least 2 of this area to satisfy this 3. But that just means at most 1 of these 3, which doesn't help anybody. This knot is kind of killing me. Look at all my scrawlings all over the board, in the hope that some of it will reveal some insight. I'm kind of tempted to look at this square because, well, I don't know. Deciding this in either direction, well, we don't know if either of these is a mine, right? They might neither of them be mines. They can't both be mines, though. So if we pick one and discover a... No. Yeah. If we picked one to, say, not be a mine... I don't know, I'm just looking at how, like, there's 2 areas that are influencing this 3 to have a 2 in, like, 2 kind of different subregions, right? This 1 is making exactly 2 mines out of this L shape. And this at most 1 here is putting at least 2 mines in this kind of rectangle. And I feel like those should overlap and interplay somehow. I guess we got a lot going up here. Like, what about this 4? We haven't really drawn anything specifically related to it, have we? It's what gave us this at most 1 because of the 5 here. I mean, this 4, it's got at most 1 of this middle band, therefore at least 3 of this outer edge. And we know on each side of it there are exactly 2. But it could be the top 2 and the bottom 2, right? So I'm not sure how that's useful. Wait, do we have exactly 1 of these 2? I wrote at most 1 here, but I'm not sure why. Shouldn't it be at least 1? Because for this 5, there's at least 1 of these 2. That's pretty uncontroversial. Which means at most... Oh no, it means at most 4 in this area. Which is, there's only 4 of them, so that's not a big surprise. It's more that there's at least 3 in this area to finish the 5. Because there are at most 2 down here as well, right? So there's at least 3 here, which means at most 1 of these. I don't think I can conclude exactly 1. That would give me exactly 3 here and exactly 2 here, which I don't have yet. Starting to have trouble even seeing the actual built-in clues. I think that in this puzzle, the most important spaces are like the spaces right next to corners. Not the corners themselves, but spaces like this 3. Right? That's where we got a start in a lot of these areas. Man. Yeah, I think we previously had at most 2 here, but that just like is nothing. It doesn't help at all. You can already tell that just from the 2. See, because this 2 is not useful. It has at most 1 in these 3 areas, which means at least 1 here. But that doesn't actually impact the 2 because it's got this corner space kind of all to itself to hide ambiguity in. But like this 2 has relatively few neighbors compared to this 1, right? So we know, for example, at least 1 of these 2. Kind of running out of space down here. At least 1 of these 2. Which means, I guess, for this 2, at most 1 of like these 4? I'm not sure that helps. Because this 3 has a neighbor relationship with 2 of those squares. But it still has a lot of other squares to work with. I just want to double check. There's really nothing I can do with this wall of 1s, right? Like, what could I say? Since there's exactly 1 of these 5, I mean, we already know there's at least, at most 1 there and at least 1 here. We could write that down anytime we want, just it doesn't seem to help. And none of these 1s have good neighboring relations with each other. These 3s next to this 2 seem important, but I'm not sure they are. Like, we have at least one of these 2, which means at most one of all the 2's other neighbors. Right? Like, well, like at most one of these 4. But it doesn't help. Does it do something to this 3, maybe? It now needs at least 2 mines in the other areas. But that's so, like, easy. Isn't it? I think so. Oh, man. I'm about ready to erase all this and just try looking at it with fresh eyes. Yep, let's do that. So I think we traced this 5 as far as we could. But let's try again. I don't know. This central area seems so important. If we could prove like one of these top 2 and one of these bottom 2, we would have, that would be momentous, right? I just don't think we can prove that. We already looked at putting at least 2 here. It's not very helpful. Wait, is it? Not quite. It almost influences this 5, but they're not direct neighbors. Right, we end up with like at most one of these and at most one of these, but the 5 could have, you know, one here and one here and still have, wait, is that useful? That looks good, actually. No, we don't get that much because this 3, okay, it has at most one here, which means there's at least 2 in this space, so we do get at most one of these. But this 3 we don't have as much information about because it has many more liberties, right? Maybe not. Because we know there's 1 here. So at least 2 in this whole area. Sorry. At most 2. No. At least 2. But it could be both of these, right? And there could be none of them touching this 3. We would need 2 of them touching this 3 for it to be an actually important clue. But I don't know, maybe at most 1 here is useful. I feel like we tried this, but maybe not. So let's see where that takes me. That means there's at least 4 in this whole area, doesn't it? We have at most 1 here, so the 5 needs 4 more. It can only hide 1 up here, the other 3 have to go down here, and we actually do finish this 3. And we also get a mine here. And then since there are 3 mines here, and at most 1 mine in this area, this has to be one of them, so this isn't. All right, the tiniest morsel of progress. Does it backpropagate at all? I think it does. Now that we have exactly 1 here, we can say exactly 2 here, which means this 3 to be finished needs a mine there. And these 2 1s share these spaces, but they don't share this space, so that's safe. Okay. What else is going on down here? We have 2 of these, and therefore exactly 1 of these, right? To finish this 3? Yes. And now this 4 needs 3 here, which finishes this 3. So this is not a mine. And we do something similar on this corner, I bet. We have 2 of these, therefore exactly 1 of these, which means exactly 1 of these, which finishes this 1. Now these 2s are sharing these 3 squares, which means there are none here. This 2 has 2 neighbors. These 2 are sharing these 3 squares, but not this one. Oh, this 2 has 2 neighbors. That's a 0. I guess we'll get back to that. Is there something going on over here? Not really. But this 1, there it is. Puts a mine there. I guess that didn't help. I mean, it marked a square, that's useful, but it didn't give me anything huge going forward. This area is still just the stuff we already knew. These 2s are good because we have exactly 1 here. And for this 2, we need at least... No. That's not so useful. Is it? Yeah, well, we know at least exactly one of these 2, but that doesn't seem so useful. I still think there's something going on in this little region here. But I don't think there's a good justification for my belief. Like, these don't actually overlap in a useful way, I don't think. I mean, we have 1 of these 2, which means 2 of these for this 3. But that's not much, right? Yeah. We have, for example, at least 1 of these 2 from this 2. Therefore, at most 1 of these 2, but that doesn't really help. It could be one of them, or it could be this one and none of these. Ugh, I hoped we were going to get a bigger break from figuring this out down here. Or from getting started down here, anyway. This area might be totally inscrutable, right? We might need help from over here. But we were stuck for a long time on the whole puzzle and eventually found a break-in here. There might not be any other break-ins elsewhere in the puzzle. We might have to break out from here. I don't know. Let's draw some stuff that I'm pretty sure I already drew in before. We have one of these, therefore one of these, therefore 3 here, which we can already tell from this 3, so that's not anything. The 3 between 2s? It can't have both of these, I guess. Because then there'd be no place for its last mine. So at most one of these two. Which I guess means at least one here. And at least one here. So I have at most one here, I guess? Which means at least 2 in this area? At least 2 in this area. Doesn't that mean something? Not really. Well, if I have at least one here, I don't know. What about this 5? We made good progress with the 5 earlier. We know there's at least one of these 3. Simply because there's only 4 over here, places you could put mines. That means at most one of these 3 for this 2. And for this 3, it means we need at least 2 of these 3 spaces. But that, we had that before, right? Right, 2, at most 2, or at least 2 here means at most one of these 2, which means at least one here, but we already had that. Could be both of them up there. Wait. Am I crazy? Is this 5 useful? Can't we say there's 1 here, therefore for this 2, 1 here? Therefore, for this 4, 3 here. We had this before. Therefore, for this 4, 1 here. Yeah, we did have that before. It means 4 of the remaining 5 surrounding this 5. Oh yeah, that is all we need. Watch. There's 1 here. I mean, I don't know. I've said that like 80 times this episode. A lot of the times I was wrong, but I think I'm right. So if there's exactly 1 in this area, then for this 2, there's exactly 1 here. Now for this 4, there's exactly 3 here. For this 4, there's exactly 1 here. And now for this 5, there are 5 spaces, and we need 4 of them to be mines, which means only 1 is missing. But we know at least 1 of these 3 is missing, because there's only 2 touching this 2. So I think we can say there are in fact exactly 2 here, and 1 here, and therefore both of these. And furthermore, now, 2 in this area means this 2 is done. Okay. That 1 has to go here. This 2 in between 1s should be useful, right? Well, let's do something simple. This 2 next to a 1 has to go there. Now this 1 next to this 1, they share here but not here. And now this 1 is finished. We can put a mine there. Still can't do this yet, I don't think. But anyway, there's 1 of these 2 and 1 of these 3 for this 1, so not here. Now this 2 has 1 mine here, and therefore the other is here. We get a 0. This is a 1 with 1 neighbor, and we can finally do this. Come on. I've been here almost an hour. Give me more. Give me more. Can we carry this back to the left somehow? We got new information over here. I think we can get something, but it's not very good. Maybe it is actually, right? We get this. Try again. There's exactly 1 here for this 1. This 2 needs 1 more, which has to go here. This 2 needs 1 more, which has to go here. This 3 needs 1 more, which has to go here. And this 2 is finished. That's better. There we go. Now this 2 has 2 neighbors. This 1 has 1 neighbor. These zeros can go. This 1 has 1 neighbor. The 1 has 1 neighbor. That's a 0. This is a 0. So is this. This is still 2 neighbors. This 2 next to 1s means there's a mine there. Still can't do anything here. I'm going to need A count. How could A count possibly help me? It would have to be like a pretty large or pretty small number, wouldn't it? Well, I think there are multiple resolutions, so I can't do this by uniqueness. And it doesn't really help to do so because I'm going to have to solve the rest of the puzzle anyway. Well, what? There's 1 of these, which means 1 of these, which means 3 here, but we knew that. This 1 next to the 2, we have 1 here, therefore for this 2, 1 here. Based on this 1, there can't be a mine here. Now the 2 next to 1 needs a mine there, and we've got this area doing something finally. Although perhaps not much. I seem to remember we learned something about this 3 a while ago, didn't we? What was it? I guess it won't be helped by this one any more than it would be by this one. They kind of overlap, so we're not learning anything very new about it, I don't think. Well, maybe we are, because if we learn something about this 3, it overlaps that one, but not this one. So what do we know about this 3? I mean, we know there's 2 here, and therefore 2 here. The worst. 2 here, 2 here. Therefore 2 here. Therefore exactly one of these. Therefore 2 here. Well, we had that before. Maybe we started from this 3 to find something out? Yes. There's at most 1 mine up here, and therefore at least 2 here. Which means at most 1 in this area. Which means at least 2 here, right? And we can therefore say exactly 2 now. Indeed, because of exactly the thing I was saying. This one overlaps with this clue, but this one doesn't. Since there's exactly 1 here and at least 2 here, there must be exactly 2 here. Which means not a mine here. Oh, and that's a beautiful one. Because now this 3 needs a mine here, or else it'll have too many next to one of its 1s. Is that right? Yes, I turned this gray. This 2 by this 1, I think it has to be here and then here, yeah. This 1 goes there, we've got a 0, chase that down. This 1 finally resolves this stuff. Really? Still not done in here? Ah, yes, we have some more to work on at least. Do we? We know 1 of these, which means 2 of these. But actually that doesn't say so much, does it? Huh. Ah, this 2 next to a 1. Now that we've put a mine here, we know the 2's last mine has to be there. So what can we derive about this corridor now? We know at least 1 here, which means at most 2 here. So for the 4 to be fruitful, it needs both of these. Now, we know exactly 1 here. So for this 2, exactly 1 here. So for this 2, exactly 1 here. So for this 3, exactly 1 here. And for this 3, exactly 1 here. And we've finished the 2. So this isn't a mine. Now these 2 1s share here but not here. And we can keep going this way, can't we? These 2 1s share here but not here. These 2 1s share here but not here. That's a mine. Oh, and yes, it's not obvious from the grid now, but apparently starting from this clue, we somehow proved exactly one of these 2, and now we know it's this one. I can't immediately see why that's true, but I proved it, so I believe myself. Should I be able to do more here? It doesn't seem like it. Huh. There's a lot of stuff that is just like very obviously never going to be resolved without mine count clues, which is a bit surprising. I'm surprised you can work it all out, right? Like, I'm not sure yet that this area... No, this area is not part of that, because these 1s have only 1 neighbor, and you can resolve the rest. But I was thinking about, like, this needs mine count. This, I'm pretty sure, needs mine count, because it's completely isolated, right? So it can't get clues from anywhere else anymore, except for mine count. And, like, this is a wire. This is all, like, unuseful. There's one here, but... like, what are you supposed to do? I don't know. So I think we need mine count, which I don't think can be a mine count, because we need it over here. I guess it could be. If we got a sufficiently low a mine count, we could say this isn't a mine. It's a long video, but I don't want to give up now. We're so close. So I think this area is where I have to work something out, but I've looked through here for a while and I didn't really see anything. All right, let's count how many mines, how many spaces of each letter are left. 4, 10, 14, 15 A's. Very far from 5. How about B's? 5, 10, 15, 20 B's. So half of these are mines. That's interesting, but not useful at the moment. Maybe I can prove something about A's. How many are there? There's definitely one right there. There's definitely another here, and a third one here. So that's 3 accounted for, isn't it? And there's at least one more in this central area. Maybe 2, but maybe not. Let's just say there. And over here, there might be one, but there might not. And here, there might be one, but there might not. So there's like 3 places that the last A mine could go. Could I maybe disprove that this is a mine, or this? That would be sort of useful, I think. Obviously, it would be quite useful. Let's not understate it. This 4 seems like the starting point for proving stuff about these 3, right? Like, if I could put a mine here, then this whole area would have no more. What if I put a mine here? This area would also have no mines, and that's impossible, right? Because we have at most 3 here, therefore at least 1 here. And we don't know which of the ones this is touching. But whichever one it is touching, it means there can't be a mine here. And we get this space. Interesting. It didn't do what I wanted. Oh, sorry about that. I bumped the monitor. I'm sure you guys heard that. Yeah, maybe these 3s are useful to prove stuff about the 4 somehow. Like, we have one of these, which we've known and derived many times, and therefore one of these. Oh, you know what? Now that we've marked this as a mine, as not a mine, these 1s are suddenly much more influential because they're exactly 1 clues on the 2 next to them, and not like at most 1, including this. So that must take us somewhere, right? Let's just look at those ones for a minute. We have exactly 1 here, which means exactly 2. You know what, let me actually, well, whatever, that's fine, here. And we also have exactly 1 here, which means exactly 2 of these 2. Yes, there we go. 1 here means 2 of these. These are both mines. Now, this 1 next to a 1 gives me this space. Fine. Yeah, we're getting somewhere now. Now we have exactly 1 of these 2, which means for this 2, exactly 1 of these 2. We knew that already. Okay. For this 1, we have exactly 1 of these, which means exactly 1 of these. We knew that already too, didn't we? No, we didn't. We also have exactly 1 of these. Isn't this useful somehow? Yes. Exactly 1 of these means exactly 1 of this triangle to satisfy this 2. But we also have exactly 1 of these, so this can't be the mine for this 2. Fuck! Oh, I was so close to finishing the puzzle. What did I get wrong? 1 of these. Yes. 100% agree. Therefore, 1 of these. Oh, this 1 doesn't have 1 of these 2. It has 1 of these 3. Ugh. Okay. Oh, so I had the right idea. I knew there was something weird going on with suddenly being able to prove exactly 1 of these. I just took it the wrong way. Right? I do indeed have exactly 1 of these 2. Because I have 1 of these, and therefore 1 of these, and then this 2 means 1 of these. But this 1 was giving me 1 of these 3. And since it's 1 of these 2, it can't be this 1. So I'm still wrong. Did I just conclude the same thing again twice? Am I insane? What? I must be wrong about this. Because I'm pretty sure this conclusion is rock solid from what I've penciled in, or from what I've marked as mines, right? There's 1 there. Nobody can argue with me on that. For this 2, there's 1 there. Nobody can argue. Oh, yeah, okay, I'm stupid. This 2 doesn't give me 1 of these 2. Because it could be here and 1 of these. And then it could be like here and here, for example. Then there'd be none here. All right. Let's try, I think I already did this, but let's try from here. I have 1 of these, therefore 1 of these. Isn't this exactly the same thing I just did? With 1 of these, I have 1 of these. And I know 1 of these, therefore this isn't a mine. Like, what the hell? I can again click the square. No. This doesn't prove that. Once again, I'm an idiot. This 1 is touching all 3 of these spaces. I don't have anything that just touches these 2, and I should stop thinking I do. Okay. Well, there are now only 7 B mines. Is that useful yet? We have 2 of them here. 1 of them here. Well, it might be better to say rather that I have another 2 of them here. And I have 1 of them here, and that's 5. I have at least a 6th here. Well, exactly a 6th here, I guess. And think I can prove something about the sixth somehow, right? Like, it can't be both of the... does it have to be one of these two? Is that correct or not? I don't think it is. Because there's one of these two. And one of these two. And that... it could be this one, for example. And these two. Yeah. But, like, maybe I could prove, for example, that I have exactly one of these two Bs. Like, suppose that I made this a mine. Well, then this wouldn't be a mine because I'd have all 7, right? So let's not do it that way. Let's instead suppose that I made it not a mine and prove this one has to be. Would be nice. So that's not a mine. Then this is, and this isn't. And to satisfy this one, we'd need this to be a mine. Wait a minute. But see, this finishes the A's, right? Because we know there's at least 3 over here. So if making this not a mine puts 2 mines into the red area, or into the A area, then this isn't a mine. And at that point, this too needs one of these. Oh, but I don't know which one. This would have to then be a mine, right? So if this isn't a mine, then this is not a mine. That's not helpful. Because now I have at least one in here, which is, I guess, exactly one here. No, it could be both of these and both of these. I'm not sure. All right, let's try again with B count. So we have 1 here and 1 here and 1 here. That's 3. This is 5. 6. Let's make this an actual 2. So we have 4 spaces remaining in which to place 1 mine. So let's first suppose this was not a mine. Would that be okay? Suppose it were not a mine, I guess. Tenses. Then this would be a mine. You know, I guess I should actually use corner notation. Suppose that were not a mine. This would have to be one. This would not. This would. And then we'd sort of be like at a loss, right? That doesn't seem to tell us too much. So suppose instead that we said this isn't a mine. Oh, that's the wrong corner. That we said this is not a mine. Then we'd have that this is, that's not, that is, and that's not. And then we've finished the A's. So this isn't a mine either, which means this is. And to finish this 2, this would have to be 1. And now that's our 7th B mine. So this would still not be 1. Right? Which means this would, this wouldn't, this would. This all seems plausible. Where did I start? I started on this one. So suppose then that I said, this isn't a mine. What do we learn from that? Well, we learned that this is, right? Yeah. And therefore this isn't. And these both are. And now this 2 says this isn't and this is. But this area is fuzzy. Where did I even start on this one? I started here? I think so. Yeah. And I haven't proved any new ones yet. But I've proven that the last A is here, right? No. Yes. Because there's 1 here and 3 here. So to satisfy these ones, you need this to be an A. So these then aren't. And this is also. So that's the last B mine, means this isn't. To satisfy this 2, we would need this. Therefore, neither of these? Is that allowed? I guess so. This all still seems possible to me. So what's the last one to try? Here, I guess. Which is what we tried first, and it got a bit confusing. So suppose that this weren't a mine. This would be one. And that's the A's done, so that's not a mine. Now this is. This 2's finished. So to finish this 2, we need a mine here. We need this to be a mine. One of these. One of these, one of these, one of these. No, this is incorrect. Not one of these. One of these and one of these, I think, a more useful way to draw. 1, 2, 3, 4, 5, 6, 7. This looks possible. So any one of those B's, it seems like, could be a mine. I guess, though, we would then have that this isn't a mine, because that's our 7, right? And that tells us this and this, not this, not this, this, not this. To finish this 2, we need this to be the last mine, not this. Still seems okay. Yeah. We found 2 A's, and there's 1, 2, 3, and this isn't a mine. Now, What if we tried to do a similar proof about the B's, but without relying on the fact that there are at most 5 A's? If we could prove that there are always 2 A's down here, at least 2, then we could prove that this space is safe. And that might let us untangle all the A's and simplify the problem in this area. So what is it that we want to do? I guess we want to assume... Didn't we try this already? Try to find a way to distribute 2 A's down here. One way would be to put a mine here and here. Does this break the puzzle? Wait, is that what I'm trying to do? I want to prove that there must be 2 A's down here. So, in order to prove that, I should assume that there's only one and find a contradiction. If there is only one, surely it is here, because there's at least one in this area. So we have none of these, and we have not this either. So we have this. And this. This 2 needs a mine there. This 2 needs nothing there. This 1 needs a mine there, and we need one here for this. No, we need nothing here. How many B's have we found so far in this area? 1, 2, 3, 4. Well, 5, 6. That's illegal. 7. And at least one more is 8. Right? So, I think I'm on the right track here. I think I just proved that this space is safe, but I'm a little nervous, so I want to double check it. What am I trying to prove? I'm trying to prove that this is safe, which would mean, let me just confirm that, if I make this safe, then there's exactly 1 A here, exactly 1 A here, and exactly 1 A here. So, if this is safe, there are 3 here, which means there must be 2 out here. Conversely, if it's not safe, can I say there must be 1 out here exactly? Suppose this wasn't safe. We'd have nothing, yes, nothing in this area, this, none of these, this, yes. So there are exactly 3 mines in this area, not counting that one. No matter what I do. Whether I put one here or not, there's 3 others. So, if there are 2 A's in this area, this must not be a mine. And if there's 1 A in this area, then this must be a mine. So, if I assume there's 1 and reach a contradiction, there must be 2, which means this is not a mine. So this is the only place we could put exactly 1 mine. Anywhere else and there must be 2. Hang on. Isn't it simpler than this? No. I was thinking, can't I just show there's none here? By just putting 1 here and there's at most 4? But no, there could be 4 here. So if we want to put exactly 1 in this area, it has to be this one. And we're assuming there's exactly 1, so I can cross this out. But I can only cross this out because I'm assuming there's only 1 in this whole area. Now, finish all the deductions. This 1 goes there. This 2 needs a mine there. This 2, no mine. This 1, mine. This 2, mine. No, am I stupid again? Did I reach a contradiction even faster this time? I think I did. Suppose this is the only mine. Nothing. 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 Mine there. This 2, mine here. This 2, no mine here. Ah. Right, this 2 already has 1. This 1 puts a mine there, and that finishes the 2 and the 1. No mine there. Now, no mine here means mine there. How many B's have we placed? 4. There's exactly 1 more here. 5. Not here, but here. There's one more here, 6. There's one more here, 7. There's at least one more here, 8. So it can't be the case that there's only one A mine in this area. There must be 2, and that means this space is safe. And this should help a lot? Maybe not, actually. Because I still don't know if it's both of these, or here, and this. Well, okay, let's try this then, right? There's only 2 possibilities. I can try assuming each of them and see what happens. This 2 needs another mine, which has to be there. This area is done. That's got to be a mine. We have exactly 1 here, so to finish the 3, we need 1 there. Also, to finish this 2, we needed 1 there. How many B mines have I placed? 3. Well, there's 1 there, that's 4. 5. At least a 6th here. So in order for only 1 to be in this entire area, we need to a little bit more, in fact, right? We need to fit 2 in this entire area, right? 1, 2, 3, 4, 5, yes. We need one of them. We need at least 1 in each of these 2 groupings, right? But there can only be 1 in this grouping, which means this is our mine over here. So this is not. So to satisfy this too, this has to be the mine, this isn't. That seems fine so far. Now we need this to not be another mine, which means we put a mine here, not here, here, not here. So this all seems possible, right? Making assumptions about these A's completely disambiguated the rest of the puzzle. 1, 2, 3, 4, 5, 6, 7 B's. Fine. Now, that means it's possible, so we can't make any huge conclusions, but let's try it the other way. Suppose we had a mine here and here. We'd then have none of these, and we'd have this. This 2 only has 1 mine now, so it needs 1 more. This 2's finished from these 2, so there. Now, this 1 needs a mine, which has to be there, and that finishes the 2 with these 2 spaces. And this 1 with this space. Fine. Ah! No matter what assumptions we make, this isn't a mine? Why? I should be able to prove that more simply. Shouldn't I? If I have exactly 1 here, then I have exactly 1 here. This just means exactly 1 in this area. I don't know. It doesn't seem obvious how I could conclude that. Anyway, we made, in this guessing universe, this a mine, so this isn't. I'm pretty sure I can click on this. I don't know. Let's just do that. Now this is a 1. There you go. I just want to get out of this dang puzzle, let me tell you. This 1 puts a mine there. And we, in fact, have all the A's, so that's not a mine. There are 5 B's, 1 here, and the 2 needs a second one, which must be there. Now there are 4 B's, 1 in each of these dominoes. Well, at least 1. And therefore none here. Now there are 2 B's, 1 in each of these dominoes, so not here. Phew, what is that achievement? Untangled? Yeah. I'm kind of sad about 2 things in this puzzle. First, the mistake that I made here twice is just like, ugh, what a sad one. And also that I had to go, like, into that that bifurcation at the end on where the A's might be. I think I'm okay with proving, I don't know. Yeah, I just the way I figured out the A's in general is not clean. So if anyone has advice, I'd be happy to hear it in the comments. Anyway, that was puzzle number 85, Endless Knot. Thanks for watching, and I'll see you next time.